Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at dividing complex numbers. So let's go ahead and get started. Now, by complex number, we're talking about something that has the following format: A plus or minus BI, where A is a real number and BI, sorry about that, is an imaginary number. This is the format. And so this is, once you know this, the second thing that you need to understand that's very important for this video is conjugates. So by conjugate, we're talking about when you have a binomial, two terms, and what it is that the conjugate is where you flip the sign of the binomial. So if I have A plus B, the conjugate would be A minus B, like so. And the interesting thing is this, and this will make more sense in a moment, when you have this pattern of A, the quantity of A plus B multiplied by the quantity of A minus B, the answer is always A squared minus B squared. This will be important in a second. And we learned this when we were learning about polynomials. So, having reviewed this background information, we're going to go ahead and see if we can take a look at our first example here for dividing complex numbers. So our first example is as follows. See that we have 2 plus 5i over 5 minus 2i. That's our first example. Now, what we need to do here is that when we're dealing with division, we have to multiply the numerator and the denominator, now listen carefully, by the conjugate of the denominator. So what does that mean? Well, the conjugate of the denominator, which is 5 minus 2i, is going to be 5 plus 2i, like so. And then we also multiply the top by the same, 5 plus 2i. Let me put a little dot there. Now, for the bottom, it should be kind of clear what to expect here. So remember what I told you about the multiplying when you have the pattern of A minus B and A plus B. The answer is going to be A squared plus B squared. Well, that's what our answer is going to be here. So in the bottom one, we're going to have 5 squared. I'm sorry, it's not plus, it's minus, excuse me. Minus 5 squared minus, 2 squared. And then multiply that by, of course, I squared, like so. That's what we're going to get. And so what ends up happening is that for the bottom, for the denominator, you have 25 minus 4. And remember that I squared always equals -1, like so. Multiplied by -1, like so. And so essentially our denominator is going to be 25 plus 4, which means that, it's going to be 29. So let me move to the next slide here. We're already running out of space. So I know my denominator is 29. I'm going to put that right here at the bottom. Now for my numerator, I have the following. I have 2 plus 5i, and then 5 plus 2i, and then 5 plus 2i. So this can be done with like a basic FOIL method or whatever, however you wanted to distribute the terms. And so to make this as quick and painless as possible, 2 times that, 2 times 2i is going to be 4i. And then let's see here, 2 times 5 is going to be plus 10. And then you have 5i times 2i is going to be plus 10i squared. And then 5i times 5 is going to be plus 25i. That's what we have. And so we combine like terms. So we got 4i and 25i. So that's going to be 29i plus 10. And then, of course, you have 10. Always remember that I squared equals -1. So 10 times -1 is going to be minus 10. So these cancel out. And we're left with in our numerator the following answer, 29i. And so, of course, 29 cancels out, and we're left with our final answer of I. So for our first example, this is our answer here. So let's go ahead and move on. Let's take a look at example 2 now. So here we got, here we got 4, and then we got 1 minus 4i, like so. And so what we need to do here now is we do the same process. We multiply the numerator and the denominator by the the conjugate of the denominator. So what that means in this situation is we multiply this by 1 plus 4i, like so. And then we multiply this by 1 plus 4i. And again, you can see we have this a minus b quantity times the quantity of a plus b. So that means that I know my numerator is going to be 1 squared minus 4 squared I squared, like so. And so, you know, this is not that complicated. We got 16, and remember I squared equals negative 1, so negative 6 minus 16 times negative 1 is going to be positive 16. And so we end up with 16, positive 16 plus 1, which means that our denominator is going to be 17. So let me go ahead. What I'm doing here is I'm simplifying what's here. And so this will be 1, this will be 16, and this will be negative 1. And so negative 16 times 1 is going to be positive 16, like that. And this is how I got my answer over here. Now, moving on to dealing with the numerator. This is not too bad because we have that single term out there. We distribute it. And so we got 4 plus 16i, like so. And so we end up with a rather unique answer. So let me see if I can make this nice and clear. And so remember that our denominator is 17. What we normally do here is that we separate the terms. So our final answer, now watch this carefully because it's a little unusual if you're not comfortable with math, is we have 4 over 17, that's taking this right here, and then we have plus 16 over 17, that's taking this right here, and then we have I on the outside like so, and that's this guy right here. Now, because they have the same, the same denominator, you can separate them like this. That's why they do that. And so this is our final answer. 4 over 17 plus 16 over 17i is the answer. Okay, we have one more example for you. And this one is a little bit different, but again, with a little bit of thought, you can get through this. So we have 3 plus 3i, like so, over 2i. Now this time is, the problem we have is we know we have to multiply the numerator and the denominator by the conjugate of the denominator. But what is the conjugate? Because we don't have the pattern that we expect. The conjugate in this particular situation will be 0 plus 2. No, I mean, this is not the conjugate, but you put a 0 there so that you have an idea of the pattern for the conjugate. So now that I have 0 plus 2i, I know the conjugate is 0 minus 2i. That's what we do there. Now, why is it positive 2i? Because this 2 is a positive number. That's why we don't put a negative there. So it's 0 plus 2i, 0 minus 2i. And you do the same thing, of course, as always, in the numerator, 0 minus 2i. Let me put the little dot there. And so we know for the denominator, we get the following. 0 squared, just follow the thought here, plus 2 squared and I squared. That's what's happening here. Oh, I'm sorry, it's not positive, it's negative. So 0 squared minus 2 squared and then I squared, like so, excuse me. And so in this process, what we end up with is let's see here, 4. So you guys know that negative 2 times negative 2 is going to be a positive 4. But remember, this time we have the I squared. I squared equals negative 1. So 4 times negative 1 is going to equal minus 4. Therefore, our denominator is going to finish at minus 4 for now. We're not quite done yet. And so the next step that we have to do here is that we have to deal with the information in the top. And so from looking at this, we have 3 times 0, which is going to be 0. Nothing to put there. 3i times 0 is going to be 0. Then we have 3 times minus 2i, so that's going to be minus 6i. And then we have 3i times that, so that's going to be minus 6i, but this time squared, like so. That's what we end up with. And so now what we end up with is we have to do with the I squared. The I squared, of course, is going to be negative 1. So negative 6 times negative 1 is going to be positive 6. So we end up with negative 6i plus 6, like so. So we're very close to finishing. So if we wanted to wrap this up, this is what we would do. We would put the 6 in the front, minus 6i, all this over 4. Now remember, we separate them. So what that eventually means is, I'm going to put the answer right over here, if you don't mind, in this circle, is we have 6 over 4 minus 6i over 4. 6 over 4 with the I. And that simplifies to basically 3 over 2 for each one. 3 over 2i. And that is our answer right there, as you can see. And I think we're done here. So let me go ahead and wrap up, explain what we did in this video, and try to conclude this as cleanly as possible. So in this video, we took a look at how to divide complex numbers. And so to divide complex numbers, of course you have to know what a complex number is. We discussed that, but it's very important that you understand the concept of conjugates, which is basically where you take a binomial and you make the binomial, you duplicate the binomial, but you flip the sign. So if it's a minus sign, you flip it to a positive. If it's a positive sign, you flip it to a negative. When you know what the conjugate is, what you do is as follows. You find the conjugate of the denominator and you multiply the denominator and the numerator by this conjugate. And so you can see the example here on this first screen. And then after that is basic algebra in terms of simplifying, like so. And in this example right here, what happened was that in the numerator we did not have a complex number, only in the denominator. But again, you still follow the same process. But what makes it unique is that when you're concluding it, the I is kind of off to the side here, because you're multiplying the number by that, and you have to separate the terms when you have the same denominator, like so. You can see that right here. And then of course we continue that with this last example where we had a complex number, so to speak, I guess, but not really, more of an imaginary number. And to find the conjugate for the denominator, we had to put the 0 there in terms of like the real number is 0, if that makes any sense to you. And then again, you go through all the basic processes of algebra, and then we ended up with the final answer of 6 over 4 minus 6 over 4i. But because you can't simplify or reduce 6 over 4, the final answer was 3 over 2 minus 3 over 2i. And that's what happened there. So I hope this video was clear for you and you were able to comprehend the complexity of dividing complex numbers. My name is Darren Thomas. Thank you for watching. Take care.